In this video, I'd like to go over homework problems 21 and 22. They have to do with mirrors. So in 21, it says describe the possible image types for a concave mirror. There are at least 4 or more different ones. Examples just describe them as large, inverted, and real. In the mirror lab packet, for lab 2, procedures 1 and 2, those are the labs that deal with this problem. So what we're looking at here is we have a concave mirror. I gotta change my pen size. Okay. So I have my concave mirror. So it's curved like a bowl. And I have some things that I know about this. I have a focal point, and I have the radius of curvature. Okay, those are the 2 things I know. So let's say I have an image. One we've been using a lot is a candle. And just for the sake of visualizing, down here I'm going to draw what the object looks like. If I can spell. And up here I'm going to draw what the image looks like. Okay, so this isn't a drawing of what the actual reflection would look like. It's just a side-by-side comparison of what the images should look like. So in that example, in the lab, in the first one they had the word mirror image, and you get to pick a letter, and it shows you how it appears, either as a virtual image behind the mirror or as a real image behind the object. But in this one, I'm going to draw, so I have a candle down here. And as I move that candle to these different places, so I have it between the mirror and the focus, at the focal point, between the radius of curvature of the mirror and the focal point, at the radius of curvature, and then from behind it. Okay, so when I'm here at point 1, my object is going to hit the mirror, and all these points are going to hit, and they're going to reflect at their angles towards the focal point, and I'm going to end up with an upright image that looks larger than the original one, and it would actually be behind the mirror if we were drawing the lines. For point 2, and we saw this with the professor in the video for lab procedure 2, he starts with his nose up against the mirror, and his face looks larger than it actually is, but it's upright. As he moves back to the focal point, his face gets huge. In this case, our candle gets huge, but it is still upright. And then as soon as he stepped beyond this focal point, candle was still giant, but now it was upside down. And I drew that one too big. Okay, so it's still bigger than the original candle. It's getting smaller though, and it's inverted. And by the time we get to the radius of curvature, our candles are the same size. It's just that this one's upside down. And then as we get past this point, our candle is still upside down, but it appears smaller. So we have point 1, 2, 3, 4, and 5. As you said, at least 4. Large, inverted, and real. So at point 1, it is large and upright and virtual. Because if we drew all of the light rays coming out and their angles to the focal point and brought them all together, it would appear upright but behind the mirror. Same thing at the focal point. It is large, upright, and virtual. Now when I get here to points 3, 4, and 5, do those over here, 3. Point 3, it's still larger than the actual candle, but it is now inverted and it is real. And then at point 4, it is not magnified. It is 1:1. The size appears to be the same. So it is, not real size, what word do I want to use here? Actual size. But it is still inverted. So it is virtual. Should have probably chosen another color instead of yellow. Too late now. And for point 5, it is small. So it got smaller than the actual candle. It is inverted. And it is virtual. And I know for me the struggle is this virtual and real, just the terminology, the words we use to describe the image is difficult. It's just a matter of repetition. Watch the videos, watch it again, find different resources, go to those Khan Academy videos. The more you hear it from different sources, the more likely you're to find a way that helps you to understand it. Okay, so for number 22, we have a concave mirror again. Okay, so we have our concave mirror. We have a focal length, so our F is 33 centimeters. Calculate the image position and image height of a cologne bottle 10 centimeters tall placed in front of the mirror at a distance of 93 centimeters. So this distance here is 33 centimeters. And then I have a cologne bottle that is 10 centimeters tall and it is 93 centimeters from the mirror. So the first question is, where is my image? And I'll draw that one in blue, and I'm just going to draw it at a spot here. Not to scale, but just draw it at a spot. An X. Some spot X. Where is the image of my cologne bottle on this scale here? Well, to find that, we go to our lab packet, and 1 over the distance to the object plus 1 over the distance to the image equals 1 over the distance to the focal point. I know F, I know SO, here I can solve for SI. So what I get is 1 over 93 plus 1 over SI equals 1 over 33. So if we do the math here, 1 over SI equals 1 over 33 times minus 1 over 93. 1 divided by 33 minus 1 divided by 93. And then I got to take the inverse of that. So 1 over SI equals 1 over 33 minus 1 over 93. Instead of writing all that out, I'm just going to invert what I have in my calculator here. Okay, so our image position, SI, is 51.15 centimeters. Image height. Okay, so for here, change colors again. Let's go with red. If we remember, magnification equals the height of the image divided by the height of the object, but it also equals the negative distance of the image over the distance of the object. Well, I know the height of the object. I know the distance of the object. I just solved for the distance of the image, and now I can solve for the height of the object. So HI over the height of the object, which is 10 centimeters, equals negative 1.15 over distance of the object, 93. I should have left the units out there to make it a little bit easier. And I punch all that in my calculator, and I get HI is 5.5 centimeters. So there's the height of our image, negative 5.5 centimeters. I can use this, since I already even have it set up here, I can use it to calculate my magnification. Let's do that in orange. So magnification M equals, and now that I have all the numbers, I can choose any of them. So the height of my image is negative 5.5 divided by our 10 centimeters, or the magnification is the distance, 51.15 of our image. Oh, no, I did those backwards. Oh, no, I didn't have those backwards. And that's 93, the distance of our object. So either one of those, so negative 5.5 divided by 10, oops, negative 5.5 divided by 10, I get a magnification of negative 0.55, and if I do negative 51.15 divided by 93, I get negative 0.55, so I end up with the same answer for the magnification. So is the image real or virtual, and is it inverted or is it upright? Well, in one of the previous questions, we looked at if we have a negative magnification, what does that mean? Check back in my notes here. There we go. So when M is negative for homework number 19, that means our image is real. And our image is inverted. So what that would mean is the image of my cologne bottle over here would be inverted. And since its magnification is less than 1, real and inverted. Alright, so hopefully that answered some questions about 21 and 22. I know the concepts, especially with everything that's going on with mirrors and reflections and all of that, can seem daunting, but just break it down into the basic math, right? You know the formulas to use. Identify what's given to you. Okay, so like focal length tells you that's the f, little f. So you know little f. The questions always give you information. Find out what you know. Find out what you need to know. And then start plugging into equations and solve for things and see if that helps you get to the answers at a minimum. It should also hopefully help you understand a little bit better what's happening in these problems. So I'm going to leave it there for today. I only have a few seconds left in this video before I get cut off. If you have any other questions or concerns, let me know. Tomorrow I will try to post the video about lenses, because I don't think I've covered that with you guys yet. So we'll talk a little about lenses. Most of the stuff's the same. It's just the light's going to be going through the lens instead of bouncing off it and coming back. So good luck. Hope you're having a great day. Get out and enjoy the nice weather while you can. And I'll talk to you soon.